Today we are going to discuss about collision detection technique. It is a continuation of the previous video. So the next topic is open addressing. So in this open addressing we are going to discuss about linear probing, quadratic probing and double hashing. So this in this linear probing, when collision occurs, we linearly probe for the next bucket, which means we will see whether the next bucket is free or not. Next space is free or not. If it is free, we are going to insert the data there. So we'll see the formula. If slot hash of x modulo s, s is nothing but the size of the table, size of the hash table. So is full, then we try hash of x plus 1. Okay, next position. So plus 1. So in that case, if this hash function is also, it gives the same value, if it is also full, we have to perform hash of x plus 2 modulo s. So in this way we can do the hashing. We'll see the example now. So just consider this hash function key modulo 7. These are all the elements we are going to insert. So first we are going to insert 50. 50 mod 7 I have to try. So 50 mod 7 is what? Reminder is 1. So at location 1 I have inserted 50 and the next element 700. So it is inserted in position 0 and the next value is 85. 85 modulo 7 it gives 1. Okay. So position 1 we have 50 already. So here collision occurs. So using this linear probing, how we can achieve, how we can resolve the solution. So we have to see for the next free slot. That is the next free slot is what? After 1, second slot is free. Second position is free. So at location 2 I am going to insert 85. So in same way next value is 92. Again 92 modulo 7 it gives 1. Hash value is 1. Again 1 it has value 50. So what I have to do? I have to search for the next free slot. So next free slot is where? At third position. Second is also occupied 85. So at third position I have to insert 92. So in this way we can do linear probing method to avoid collision. So once the space is empty, we are inserting it. If not, we are moving to the next free space, very next free space. So in this way, linear probing is done. Next is quadratic probing. So in quadratic probing is same like our linear probing, but here what you have to do, instead of 1, 2, 3, we have to multiply it. Okay, I square the slot, 1 square, 2 square, 3 square. So something like that we have to do. Here also we are going to search for the next free space, but we have to do it in quadratically. That is I square, that is 1 square, 2 square, 3 square slots. We'll see how we can achieve it. So these are all the elements we are going to insert as first element is 50 and 700, the same like the previous one. So initially our table is empty. So now I am going to insert 50, then no issue. Here collision will not happen because this is the first element. So I am inserting in location 1 because 50 modulo 7 it gives 1, right? So at location 1 I am inserting 50 and next is also 700 is also inserted nicely, and 85, when you insert 85 modulo 7 is 1. At location 1 you have 50. So what you have to do, collision occurs here. So we have to use the formula, that is 1 plus 1 square position. Okay, 1 square position is what? 1 into 1 is the next position, right? 1 plus 1 or 1 plus 1 square, that is 2. At second location, I am going to insert 85. So likewise 92. When you insert 92, it gives the hash value same, like 1. You will get index value as 1. So here you cannot insert because 50 is there. So I have to search for the next space. If I try 1 plus 1 square, I'll get 2, right? So at 2 also I am having 85. So I cannot insert. So what I have to do, as per the double hashing technique, I have to go for the next I square value. So 1 square, instead of 1 square, I am trying 2 square. 1 plus 2 square. So 2 square is what? 4. Correct? So 1 plus 4 is 5. 5. So at location 5, I am going to insert 92. So in this way I can do it. So this 1 is nothing but the index position, plus 4 is nothing but the I square value, and when you add you will get the hash value 5. So at fifth location I am going to insert 92. So in this way we can do quadratic probing.